Hi, this is question 10 then. In the assess it says P and Q are both positive quantities. P is inversely proportional to Q. Let's start doing the work here. Pen, where are you? Okay, P is inversely proportional to Q. Right. No squares, no nothing? No. Right then. So therefore A, express P in terms of Q. Let's get a constant proportionality. So I've got P equals K over Q. P is 15, so 15 equals constant divided by Q of 12. So K is going to be 15 times 12. Grab a calculator quickly to save time. 15 times 12. Besides, I don't know what 15 times 12 is. So 180. So what's my formula? P equals 180 divided by Q, and that is my formula. It's ready to go. Part B, well, that was A, all that kind of thinking. This is B. What is the value of P when Q equals 10? Okay, right, I've got a formula. P equals 180 over Q. Substitute 10 into that. P equals 180 over 10. I can see the answer is 18. Part C, what is the value of Q when P equals 10? Okay, quote my formula. This time P equals 10, so fine. 10 equals 180 divided by Q. Cross multiply, Q goes up, 180, 10 comes down, chop it off, Q still equals 18. Lovely, no problem. Sketch a graph of P against Q. So lovely, here's a graph of P against Q. Now look, what have I got here? I've got a 1 over X type graph, and that's going to be one of these beautiful looking curves that do that. Alright, so that's the graph of P equals 180 over Q. So P against Q will look something like that. I think that's correct. Right, that's that one done. Next one, here are some sketches. I've got to match each graph with each of these scenarios. I've got y equals 20x. That's clearly based upon y equals mx plus c. If it's 20x on its own, the intercept is going to be 0, 0, passing 0, 0, and the gradient is going to be 20. Is that alright? It's a straight line graph. Therefore, y equals 20x goes with graph Q. Graph Q. They're together, they're friends. Next one, B, I've got y equals 20 over x. That's essentially a 1 over x type relationship. It's one of these things that go whoosh like that, and therefore put the answer in there. Y equals 20 over x goes with this graph here. Now, and I'm left therefore with this one being graph R. I need to show you why that is. Look at that, y equals something to the power of x. Therefore, if we have a power of x, we can have an exponential increase and times 20 as well. So, ooh, what can I say about that? It's really going to start taking off. And therefore, y equals 20 times 1.5x, the exponential looking graph, is going to be graph R. I'm just going to pause and check and I'll be back. Yeah, no problem, perfectly right. Let's move on. Right, this is the AQA question on page 63. It's not graded, but it's, you know, it's at least grade B because of the, well, you'll see in a minute. Right, the size of North Sea cod stock in 2008 was estimated at 250,000 tonnes. Because of overfishing, please note politics, it is decreasing at the rate of 11% per annum. That means per year. How many years will it be before the North Sea cod stocks fall below the critical level of 70,000 tonnes? In other words, how low can we go before they start to die off permanently and we have a chance to reproduce and feed us cod and chips again? Well, it's a percentage decrease in a repeated sense. So I'm going to take my 250,000 and multiply by, if I'm dropping by 11%, I'm still 0.89% of that if I drop year on year. Now, if I multiply that just by power of 1, that's not going to drop a great deal. I'm going to try 5 years and see what happens. Right, show you working. How many years would it be before this drops below that? So let's just try 5 years and see what happens in the first instance. So 0.89 powered up to 5, and then multiply that by 250,000. Alright, I'm on to 139,000 at the moment, 139,601, and that's in tons, isn't it? So I haven't reached anything like yet. Let's just try, I don't know, 8 years and see where we go. We're still dropping at a projected 11% per annum, and so per year. Let's just try 8 years and see what we've got there. Again, it's trial improvements. 250, 123 multiplied by 0.89 powered up to 8 years. Getting there. I'm on 98,414 tons. I've not dropped below that yet. Let's go for another couple of years. So 250,000 multiplied by 0.89. Let's go for 10 years now. It's getting quite close. Let's do that. 0.89 powered up to 10 multiplied by the original 250,000. Oh, look at that. I've got 77,954 tons roughly. I'm not rounding anything off, just leaving it like that. Let's just go for 11 years. So 250 by 0.89 powered up to 11 is going to be, so 0.89 powered up to, wrong, 0.89 powered up to 11 years multiplied by 250,000. I think I've got it. There it is. 69379 tons. Right. Question: how many years will it be before the North Sea oil cod stocks fall below the critical level of 70,000 tons? Answer: I just dropped below 70,000 tons after 11 years. Therefore, 11 years. Don't have to justify any further. It's 11 years. I've shown all the steps in my trial and improvement, and there's no other way to do it really. Lovely question. Now this one is completely, well, it's really, really difficult. Reading it alone to get your story straight in your head is really hard. It's a difficult thing, certainly grade A. It says 75 scientists are trapped in the Antarctic. Okay, irrelevant. I reckon the 75 is going to be quite important. They have enough food for 30 days if they have full rations per day. Now after 16 days on full rations, a rescue party of 9 people came. The rescue party brings enough food to increase the existing supplies by 60%. Now the existing supplies are 14 days of rations. The weather gets worse, blah de blah de blah, everyone gets trapped, they decide to go on half rations. That's important. Here's the question: how many more days before the food runs out totally? Now let's look at this carefully. I've got 30 days full rations for 75 people. After 16 days of eating a full rations per day, more people arrive, bring them some more food. All of a sudden they bump up the stocks by an extra 60%. The weather takes a beating. Everyone sits there in their tent starving. They decide to go for half rations. How long before they all die? Right, this is essentially it. Right. I have got one person's worth of rations, is going to be, I've calculated it here, 75 scientists multiplied by 14 full rations. You see? So imagine we've got 14 days left shared amongst 75 scientists. So if there was just one person alone, that person would take all 75 of these 14-day full rations. Now that's going to come to 1,050 daily rations. These are full ones. Is that alright? Have you got that? You've got to do this in ratios. Honestly. Yes, it is ratios and proportions, but so what? It's daily rations. Ah, yeah, it's alright. Daily rations. So there you go. If it's just one person that can survive for 1,050 days all by themselves on full rations. Now, these 9 people come and they bump up the supplies by an extra 60%. In other words, I'm going to take my 1050 days of full rations and multiply by 1.60 to see how many full days of rations I've got available to share out. Now here's me working out earlier. I worked it out to be 1680 full rations. Alright, now I'm going to take my 1680 full rations and divide it by these 75 scientists and these 9 extra people. So 75 plus 9 is 84 extra people. So I'm going to share out all these daily rations by 84 people, and I get an answer of 20 full rations each. In other words, they can each survive on food, full day's food, for 20 days. Now, it says here they decide to go on half rations. Okay, therefore if you're going to have half rations, that means you can go twice as fast. So 20 times 2 equals 40 days. Alright, now that's quite tricky to get your head around that one. So on 40 days, so what we've got here, okay, one person will take all the food, say, so 75 people's food times 14 full days, 1050 full days rations, alright, full dinners, no problem. Now somebody comes along, in fact 9 people come along and bump up the stocks by 60%, so multiply by 1.6 and get 1680 full rations. Now unfortunately this person's not by themselves sitting there for about 3 or 4 years just chomping away on full rations. We have 84 people to feed. So 75 and the 9 are 84, so you divide 168 by 84, we get 20 full rations. In other words, these 84 guys can survive for 20 days. But if they say, well actually no, we can survive on half rations, you can therefore go and survive for twice as many days on half the food, so it's 40 days. And that, friends, is your answer, and that is the end of percentage and ratios. We've done some difficult, dodgy stuff. You've got to look over this one, certainly this direct and inverse proportion. If we need to do further practice in school from the old scheme, because there's lots of these in the old book as well, then we'll do that as well. If not, then this may be enough for you. See how you feel about it. In the meantime, you've got to study this video.